Noise operator in C programming. Okay. Previously we checked out this one, right? Right shift and what is it called? Left shift. So the goal is to check whether we can use this bitwise operation to check integer overflow. Debug, okay. Utils. Okay, what is it called? Scripts, okay. Print decimal 1 2. Okay. Now we shifted by 1. Let's put this in here and wait. In here, right? To see the pattern, you know. Okay. Then 3. Okay. So we are shifting the bit and 26, 53, 106. Okay. Now I'm kind of curious. Even if we use 31, 0. Oh, okay. If 30, also 0. Interesting. Egg is also 0, huh? Okay, interesting. So, what about the maximum value here? Okay, interesting. And then you shifted by 1. Nothing. We shifted by 2. Still nothing. How many is this? 29. We shifted by 29. Oh, okay. Right, what is it called? The value changed by 1. Okay, I didn't realize that. This one, okay, 30. 130. interesting. Okay. Oh, okay. And how many is this? 32. Okay. 32. 31 become 1. 32 become 0. What about this one? 31, okay. What happened when okay. Wait. Still, interesting. This one, right? Okay. False. Long makes. Let's see. Okay. Zero. Interesting. So yeah, I think we can do this. How many do we have this? Okay, 32. Okay, so maybe we can do something like this. 0, right? Very constant donuts. Okay. Not equal 0. Return alpha. Value count. Got integer overflow. Okay. Run main debug. Okay. Utils line 20. Okay. Break utils. No. 20, right? Wait. That one, okay. Run, no. 69. Break right, print. Value count 1. Okay. Let's change that to no, I haven't saved that. Okay, let's check the limit first. Okay. And then let's take a break. I guess step right. Okay. So the previous condition does not meet. Okay, let's run again. 69. Print. Let's check. This condition should be triggered. Okay. Return alpha. Okay. Value count got integer overflow. Now let's try again. Okay, simple. Let's try this kind of complex example. Okay, continue again. Okay. continue. Should I call it as value count cut integer overflow? I mean, for me personally, this is more readable, I guess. But yeah, let's just go with this for now. Okay, let's add some notes. I got too many. I should read integer type. Integer type value count. If I can type correctly, integer type for value count. Okay. Integer overflow. I mean, like Marlowe. Okay. I think there is this one, I guess. I mean, like, should we try preventing integer overflow in this? Yeah, I'm not sure. Why we got the segfault? Interesting. because, well, we provide more count than the actual count. So when we try to evaluate the expression, we can even access the value. Can even access the memory address. Okay. Is memmove have integer overflow? What is it called? Checker or something like that. The memory allows me overlap, copying text. Copies inputs from memory area source to memory area test. Hello. You just woke up. Okay. Welcome. Okay. So I try to handle integer overflow. Let me demo that, I guess. Oh, nice. Okay. Good luck with that. I don't know about C++, but yeah, it can be interesting, creating the interpreter. Okay, so let's say we have this, what is it called? Limits.h and max. Okay, I added this. Okay, so I'm trying to check integer overflow with bitwise operation like this, right shift 1, right? So if we print this, it is 0, and well, we print the binary, it also 0. Yeah, because this one, right, the binary, and then we do right shift 31 become 0, and the interesting part is that when we use more than 1, it becomes 1. So I'm kind of depending on that, I guess. Let's try long max. The long max. This one. See, 1. So it's not 0 anymore. Yeah, that's basically it. Oh, it is similar to C, but the concept. Okay. Because I've heard some people say that C++ is kind of different, way more different than C, but yeah, I haven't tried that, so I'm not sure if that is true or not. Like how similar C++ and C is, right? That is the part that I'm not sure yet. Okay, good luck with your exam. Then events can are thrown to code engine, and it has many different ways. That's the one thing. Oh, okay. Alright. Okay, thanks for the explanation. Maybe I will take a look at C++, but who knows? Okay, let me... That's why it is difficult and different from C. Okay. Yeah, that is the challenge. Alright, good luck with your exam. See you next time. Okay. Bye. Alright, focus on your exam first. Alright. I don't think I need this one. I think I should add this one as a reference to give credit, right? I mean, I found out the inspiration to do bitwise operation from this article, especially from this one. It is interesting. Half mark sign. Okay. Let's you know what? Let's beat that. Okay, commit. Print out empty bracket when pressing enter. When only pressing enter. Is that prevent print empty bracket when only pressing enter. Previously, when we print enter, we pressing enter without any what is it called? Any expression, the number or reason we got one output. Not this one. Now we got a space. Got a space. Oh, I'm trying to learn C. Hello, welcome. I'm trying to learn C by reading this book. I will copy this in the chat in case you want to check that out. And this book give us a project to put a Lisp interpreter. Lisp basically a programming language. Let me search that. This one. Lisp basically programming language like Python or JavaScript. So let me copy this in the chat too. So I'm trying to create a simplified Lisp interpreter with the guidance from this book, to build your own Lisp. But the point is still learning C because I'm still not familiar with Lisp myself. So yeah, that's what I've been doing. Welcome. Saltagrau. What? I'm not sure I'm pronouncing your username correctly. Okay, let's try that out. Okay, welcome. Let's learn together, That's the point of this live streaming. I'm also still learning. That's why I'm not sure if I can explain that correctly or easier to understand. Okay, so previously we tried out preventing integer overflow. Let me finish commit message first. Okay, so what basically this changes did is that when we press enter, we don't have a bracket around that. Let me abort that first, I guess, and let me show that git test. Okay, and then compile that. Okay, when I press enter, it print out the empty bracket, which is not what I want, so that's why. Right, okay, and then compile again, and when I press enter, this is still not a nice, a nice experience, I guess. We are not printing out the empty bracket, but we still have this empty space. I wanted something like my cell prompt like this, or maybe best to make it easier. Right, there is no space between prompt, so I'm still not sure how to do that yet. Okay, that's what I'm trying to commit. Okay, one step at a time, Git commit. Okay, empty bracket when pressing only enter. Previously, when we sing only enter without number or in or expression, number or expression in the prompt, we will get empty bracket as an output. These changes prevent printing out empty bracket when there is no input. But we still have not got empty line because of I think I knew the problem. It is in the butcher, this one, right? If we comment this, it should be like the base here doesn't have empty line in between. Of alpha print butcher in alpha print still not sure how to handle that yet. Okay. Okay, and then let's compile that again. See, it is similar to this base prompt, right? But the problem is that it didn't. Okay, hello, welcome, Need Learning. Keep it up, it looks awesome. Thank you. Oh, I'm jealous of your teamwork skill. I mean, we can learn, you know. Yeah, I mean, I spend a lot of time using Tmax, so yeah, that's maybe it. But there are a lot of things that I feel like I'm still not sure about Tmax, you know. So yeah, I'm still learning how to use Tmax. Don't worry about that and keep going. That's the point. Okay. Yeah, I'm still not sure about how to handle this one. So, I don't think I need this anymore, yeah. Is it in this one? Okay. We're preventing of, oh right, okay, for the one who, what is it called? For the one who just joined, I think, let me, what is it called? Let me introduce briefly what integer overflow means. it's basically we have a maximum value for integer, right? And if we exceed this value, the behavior can be unpredictable or predictable depending on the integer we use. So there are two kind of integer, signed and unsigned. If I can type correctly. Signed and unsigned. For the signed integer like this one, the default, as far as I know, is signed integer in C. Like this one, the a variable. If it is signed, the overflow behavior is undefined, so we have no idea what's going to happen. But if it is unsigned, like this, it is basically a modulo. I think I have an example in here. Okay, it's basically like this. It is... no, not that one. I think... oh yeah, this might be it. Okay, it's a modulo. So in this one we use unsigned in, and if we take a look at this is the maximum value of unsigned in my machine. And the definition, if I remember correctly, is that one value greater than the maximum value on the machine for the unsigned integer. So in this case, 4294, 967 to 95, and one value greater is this value, right? So basically the real value modulo by the one value greater than the, what is it called, the maximum integer value. Let me try to run that. Yeah, something like this. 3, because well, we are using this value, right? So it is 0, and then 1, and then 2, and so on. And for the signed integer, alright, the difference between signed and unsigned integer is that, as far as I know, signed integer can have a negative value. I mean, this is the simplified explanation because I'm still not sure what's going on under the hood. But the simplified version is that signed integer can have negative value, while the unsigned integer did not have a negative value. In integer overflow background, I guess. Okay, see, it should be, wait, let's see. Okay, it should be 2147 483 647, but we have the negative sign in this E2 variable, and the ini is because we are using shortmax. Okay, it's this one, right? Okay, so that's the case of it. And in this, where is it? In these changes, let me just So this instead, in these changes, what basically I'm trying to do is preventing the integer overflow with the bitwise operator, you know. So when the value, the count value is not the count value using the redshift operator, the bitwise operator not equal 0, we return an error. I think I can demonstrate that. Main debug GDP, what is it? Okay, let's add breakpoint in utils.c. If I can type correctly. Oh my god. Utils.c line 6, no, not line 16, line 25. Okay, and then run. No, 69, and then print value count, right? And then if we change that to this one, I think, okay, this one, I think one value greater than the maximum integer value, it become negative, right? For whatever reason. And then we try to continue again, it throw an error. Value got that integer overflow. But if we, let's say, did not change, did not have integer overflow, it's working fine. Okay, that's basically it. Let me compile that first, not compile, commit this first. Git commit, okay. Value count got integer. Handle overflow. What is it called? When have too many expression, having to this out with but this method not this one. We will hit the maximum value for if we will hit if we will have too many in one statement and get integer overflow from count, let's try adding a safety card. With evaluation count. Okay. Let's see how it goes. Let's see how okay. I'm still not sure. I mean, like, should we try handling integer overflow in this section too? Like, but this one, C programming, check integer overflow, multiplier, I guess. I guess I can also use right shift open modification. When each key1 is stored in a 32-bit signed integer, you can by computing the full double width product of the signed integer, then right-shifting the result by almost okay. When it's can generate full double width product of the sign, then right-shifting the result by 31 bits. Sorry, because twice, and the shift acts as activation that move one instance. Wait. Let me this method is on 64-bit system. Might not work. And the save act as a division that removes one instance of the scale factor. We can compute the double width product by computing the upper and lower 32 bits of the full product. The lower 32 bits are computed trivially. To compute the upper where is it? My move. Take my move is small lock. Size, right? See, move. What is it called? Memory overflow. Dun, 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 dun. I, error checking on I method. Okay. Okay. Yeah. I think this is fine, right? Remove the element of I, because the one who will get in trouble is count, right? I mean, cell is pointer of pointer, so this is the value of pointer, and this one is already handled in this, what is it called, in this snippet, in this section, and this is just reducing, right? We're basically eliminating, reducing the memory. We create new memory with the radius size and then move from this one to destination, the new memory with the radius size. Okay. I think that's okay. Okay. Alright, then let's move on reading the book. I've spent a long time not reading the book. Okay, we already implement quote expression. Is basically we did not, what is it called? We did not evaluate that and just print it as is, like this, for example, right? And if we do this instead, it will be evaluated. Okay, so we already done this quote expression, and then okay, first time I don't really use this macro, mostly because of this, right? When I see this, I might forget that this should be the negation of the condition, rather than as is. So yeah, I don't really like getting those fake and just use if else statement. Join. We already done this too, right? Okay. For anyone that recently joined, let me demo that. So it's basically like this. What this means is that we evaluate tail, and tail means that we, what is it called? We remove the first item with its tail in here and use the rest of the item, which is here. So what we did is basically evaluating this head like this, right? And what is here means we are converting from the symbolic expression to quote expression like this. So we can actually do this too. Yep, that's basically it for this chapter. Okay, immutability. Let's take a break first. Oh, hello. Welcome. Let me go to the bedroom first. I'm back. Well, I like to switch my chair once in a while. Either the normal chair or the, what is it called? The yoga ball. Using yoga ball as a chair can be quite fun, you know. Okay, let's check what we have done so far. This is just the integer overflow handler, right? Okay. Leave an empty bracket, okay. And then this is all right. We also try stack overflow example, which is quite interesting. Let me, what is it called? Let me demonstrate that, I guess. So Stack Overflow. Yeah, it's not about the website. So basically there is a limit when we, what is it called? When we call the function, I guess. I mean, like we put it on the call stack. So every time we call a function, we put the memory of the function into the stack, and the stack have a limit. So if we exceed the limit of the stack by like this one, calling a bunch of function without actually exceeding, we will have Stack Overflow, and that causing segfault or maybe some weird behavior. I'm not really sure. So let's add a breakpoint in line, I guess in line 16, and then run, right? No. Okay, what is it called? Info break. We hit that break one time, and then let's say we continue for 10 times. We got a segfault, right? We exceed the limit of the stack. And the interesting part is that we have one more hit, one more continue execution, right? And we run again, the breakpoint already hit 2 times, so the previous ignore hit is running again when we supposedly start from beginning. It is quite interesting. So yeah, that's a little bit about Stack Overflow. And in case if you want to check the repo, it is in here. Let me copy this in the chat. If anyone wants to check the repo, I mean, I haven't made the readme yet, so yeah, that's it. It is work in progress. Oh, and also I think one of the interesting part is that, where is it, run script, right? I'm trying to use static library, I mean, I'm not really creating this interpreter from scratch, like creating the parser from, let's say, what we did like this from scratch, like parsing the plus, the 69 and 1 from scratch. I'm using a library called this one, MPC, Micro Parser Combinator. Let me put this in the chat. So I'm using this library and the, what is it called? The book, right? The book suggests us to use this command, right? To use this command is basically means that we are also compiling the mpc.c as far as I know, right? So we are not only compiling this and also compiling mpc.c and then link together to make one executable file. And the problem is that compiling the parser can be slow. At least it is not as fast as the current implementation, as fast as when using the static library like this one, lib mpca. So here's an example when that took a while rather than just instantly. That's probably a millisecond. I'm still not sure, but yeah. The point is that I want to try things out right. So why not trying using static library? And if you are curious why I didn't use set library, so in C, wait, I think I have the reference here. In C there is this static and set object, or maybe archive. I'm not really sure. This one. Right, let me put this in the chat in case anyone wants to see that too. But yeah, there is this archive or maybe static library. I'm not really sure what it is called. Let's call it archive, I guess. Archive library and set object libraries. I haven't succeeded in using the set object libraries. So yeah, I'm still not sure how to use that. This is called static libraries now. So is it archive library or static library? I'm not really sure. So yeah, if you want to try this out, you can check the repo, my repo, and try things out on your local machine. See, I've tried this, but haven't succeeded yet. Okay, anyway, let's continue with chapter 11. Okay, immutability. In the previous chapter, we have made considerable progress. Okay, we already can do a number of cool things. And this can, such as putting code inside a list. Now is the time to start adding the feature which will make our language practical. Okay. The first one of this is going to be variable. Right. That's right. It's a misleading name. Oh, okay. Because one okay. Because our variables one vary, right? Okay. I guess that's where the term variable came from. I'm not sure. But it is another way to look at it. Our variables are immutable, meaning they cannot change. Oh. Everything in our language software has acted as if it is immutable. Right. because I'm not sure we changed that in GTP, not in the language itself, not in the interpreter itself, right? Okay. When we evaluate an expression, we have imagined that the previous thing has been deleted, and a new thing returned. In implementation, often it is easier for us to reuse the data from the previous thing to build the new thing. But conceptually, it is a good way to think about how our language works. Okay, and a new thing return. Reuse, right? Okay, so actually our variables are simply a way of naming values. They let us assign a name to a value, and then let us get a copy of that value later on when we need it. Okay. They let us assign a name to a value, and then let us get copy on when we need it. Okay. So we are storing the value with label, I guess, and that label is the variable. Wait, does variable stand for variation label or something like that? That is an interesting way to look at the variable. Variation of label, right? They let us assign a name to a value. Yeah, that's quite interesting. Is variable means variation of label? Yeah, I'm not sure. I'm just making that up. I have no scientific backup for that. And then let us get a copy of that value later on when we need it. Let us get when we need it. To allow for naming values, we need to create a structure which stores the storing name and value of everything in our program. We call this the environment. Oh, okay. When we start a new interactive prompt, we want to create a new environment to go along with it. Start a new interactive prompt. When we start a new interactive prompt like this one, this is basically a prompt, right? It's like, when we call a Python interpreter, right? It's kind of similar, and that's what I mean creating a simple interpreter. I mean, I don't expect this to have a lot of features like Python interpreter, because the goal is to learn C. goal is to learn C by creating a simple Lisp interpreter. So yeah, the point is to learn C rather than creating an awesome Lisp interpreter. But maybe we can create something decent, something good enough to calculate some numbers. Who knows? This the environment. When we start a new interactive prompt, we want to create a new environment to go along with it, in which each new bit of input is evaluated. A new environment in which each new bit of input is evaluated. Then we can store and recall variable as we program. Okay. Send a name to something new. Yes, that is mutability. When we, in our Lisp, when we reassign a name, we are going to take the old association and create a new one. Oh, okay. So it is mutable. This gives the illusion that the thing assigned to that name has changed and is mutable, right? Mutable. But in fact, we have deleted the old thing and assigned it a new thing. This is different to C, where we really can change the data pointed to by a pointer or stored in a struct without deleting it or creating a new one. This gives the illusion that that name has changed. Deleted the old thing and assign it a new thing. This is different to C, where we really can change the data pointed to by a pointer or store in a struct. Oh, okay. So we are not changing it, but delete and reassign something new. But yeah, the point is that we can change that, even though the underlying mechanism having this delete and assign new thing. Okay, symbol syntax going to allow for user to find variable. We need to update the grammar for symbols to be more flexible. Okay. Rather than just all built-in function, it should match. Okay, let's take a look in scripts. This one, right? So we're gonna change this. I mean, currently I support double by default to make things easier, I guess. And that's why when we use this, it print out like this. Okay, well, maybe we can handle that. I think like instead of number we can add decimal, but yeah, let's think about that later on. Other than just RPN function, it should match any possible valid symbol, unlike in C, where the name a variable can be given is fairly restrictive. We are going to allow for a sort of character in the name of a variable. As follows. Okay, alphabet and number, lower and uppercase, plus using plus as our variable name. Is that it? Paste our hand into the keyboard, right? Well, that's what regex is. Right. Okay, let me try to decipher this. This is lowercase of alphabet, and this is uppercase of the alphabet, and this one is the number 0 from 9, this one underscore, this one plus symbol, and then this one is the negative symbol, this one is the star symbol, usually for the multiplication, and this one is the backslash symbol, this one is the, what is it called, the slash, oh sorry, this one is the slash symbol, and this one is the backslash symbol, this one is the, I guess, the equal symbol, this is the, what is it, less than, and this is the greater symbol, exclamation, ampersand, and yeah, that's it. That is the symbol that we use. And this square bracket means that for every symbol or character in this bracket, and then we add the plus, which means that at least one or more of this symbol. That is as far as I understand this regex. Okay, actually it is a regular big ring specifier, right? The square bracket inside a range specifier is a character lose their meaning, but some of these characters still need to be escaped with backslash. That's why we have this one, right? Because minus symbol usually stand for range, right? This one, 0 range until 9, right? So we need to escape that using backslash, and the backslash itself need to be escaped, right? Because, well, we can do something like this, right? To escape the equal sign, I guess. Because this is part of a C string, we need to put 2 backslash to represent a single backslash character, right? In the input. Oh, wait, hold on a minute. Does this mean that this is, what is it called? One character? Like this one in backslash, right? This one is another backslash. And this one is... Okay. Let's try this out instead. Oh, but we don't really... Yeah, why is it 2? Interesting. Or is it for the, you know, the, what is it called? The symbol. I mean, if we want equal sign, only 2 backslash needed, right? Why do we need 4? That is interesting. Let's continue first, I guess. This rule let symbol be any of the normal C identifier character. The arithmetic operator character, okay. Slash, right? Oh, okay. Yep, so I guess I was mistaken. This one is 1 backslash. So we are not escaping the equal sign. We are providing the backslash sign. I think I remember doing this in FilmScript. Yeah, so there's that. This is the backslash character when we need to escape the escape symbol. Right. Okay. The comparison operator character. See, right? This does not mean we are escaping the equal sign. It's just a representation of backslash. This one equal to this one. escaping the escape character. Okay, but yeah. Okay. I mean, if we only use 2, right? Then it just mean backslash equal sign. Yeah. And that mean we are escaping the backslash. We are escaping the equal sign instead of using that as a backslash character. This one. Okay, or an ampersand. All the flexibility we need for defining new existing symbol. Okay. Okay. So we are not using this one. Function pointer. Symbol will no longer represent function in our language. Okay. Function in our language will represent name. Okay. And get some new value back from. Therefore, we need a new value to represent function in our language. Once one of the built-in symbol is encountered, there is something called function point. Therefore, we need a new value to represent function in our language, which we can return once one of the built-in symbol is encountered. To create this new type of alpha, there is something called function pointer. Okay. Pointer are a great feature of C that lets us store and pass around pointers to function. Edit the data pointed. Instead, we use them to call the function they point to, as if it were a normal function. Interesting. Function pointer. Like normal pointers have some type of associate with them. This type specifies the type of the function pointed to, not the type of the data pointed to. This lets the compiler work out if it has been called correctly. Specifies the type the function pointed to not the type of the data pointed to. The compiler works out if it has been called correctly. Next pointer to a new function. Why are we using type def? Alpha. Yeah, why are we write it like this? I mean, this is a built-in function, right? A new function pointer. Wait, let me check that out. C programming function pointer type. Is that the word? Function pointer in C. Is this the one? A type of pointer that stores the address of a function. Oh, okay, interesting. Let me take notes of that. Function pointer. Function pointer. Okay. Function. Wait. address of a function. Oh. Memory address. Of a function. I mean, I'm kind of know that we also can print this one, right? The main function pointer, like this. The holy. See, this is the main function pointer. The memory address, sorry. This is the memory address of main function, memory address of argument count, memory address of argument vector. I mean, let's try this out. Holy see. In the holy. Is it the same? Oh. It is surprisingly the same. Or not. Yeah, no. Nope. That is not the same. And this kind of make me wonder. KCC, holy sea, the holy sea. Oh, okay. Interesting. So it is also printing out the same memory address. Okay. That is quite interesting. Allowing function to be passed as argument and invoke. Oh wow. Function to be passed as argument to another function. Oh. This is useful in techniques. Callback function. Okay. Event-driven programming polymorphism. A function or operator behave. Okay. This is quite interesting. Then we can call Okay. Let me put this in the chat in case anyone wants to see this too. I mean, this example is kind of redundant, I guess. We can just use add function directly, right? But well, maybe in some cases this method can be used. some pointer declaration. Declare according to the return type. Okay, so what this means is that this is the return type eval pointer or pointer eval, the return type, and this is wait a minute. Hold on a minute. Is it pointer of pointer? Does this mean pointer of pointer? Is that it? Interesting. In some places, the syntax of C can look particularly right. Okay, it can help if we understand exactly why the syntax is like this. Let us deconstruct part by part, okay? The type def, because if I remember correctly, in the book we are using type def. Let me cross check that. Is it in parsing? Or not? I mean, we need alpha in the evaluation. But I guess in symbolic expression, okay. See, we are using type def, right? But I don't really use type def in my implementation because I like the explicit nature, like the explicitness. Is that the word? Like this one. When looking at this, I know that this is a pointer to eval struct, you know, and it's also the same with enum, but in the new version, yeah, I guess we don't really use enum. Oh, yeah, we use this, right? With this line, I can just think of type as eval enum eval type, something like that, without needing to actually going to this enum definition, right? Okay, that's just personal preference, I guess. So we need to adjust this. First, the type def. This can be put before any standard variable declaration in the name of the variable being declared a new type. matching what would be the inferred type of that variable. This is why in the above declaration, what looks like the function name become the new type name. New type name. The new type name. Okay. Next out. Need the star on the left hand, not the right hand side of the type. Okay. Inference. Create new in. It is meant to read variable x where to result in an n. Okay, I guess. Therefore, x is inferred to be a pointer to an n that is extended to function pointer. Return alpha. Okay. Return pointer alpha. So maybe in our case, we should use something like this. File built-in the value that the function return. Parameter type, okay. The name of the function pointer. The parenthesis around the pointer name is necessary, okay, as a function declaration. Oh, with the return type of return type pointer and name pointer. Okay, so it is a different type of declaration. Okay. A pointer to a variable, the address of a function, the function to be called indirectly, event-driven function, event-driven programming. Okay, we will learn how to declare and use. Okay. Let me check on the Google. modifier in the middle. Declaration reflect use. Okay, am I a robot? Let's find out. The motorcycle. I think I am a robot. Let's see. Oh my god. I am a robot. Okay. Is this there? I don't think so. Okay. Wait, what? Excuse me. Oh, the pointer section. What? Is this a valid syntax? What is this C++ syntax? Oh. Okay, I'm human. Fortunately. Creation effect. And use of this one. I mean, is there a difference? Oh, or this one. Okay. to make the syntax variable centric rather than type centric. And then if I write the result in an int, doesn't reflect use. Oh, declaration reflect use. So the declaration reflect its usage. Is that it? But then okay. Is this it? Okay. Right. There is a program to translate C syntax to English. Let me copy this in the chat. I'm not sure if I have that on the reference here. Can I edit? No. Character. Okay. Character. Two more. Okay. Let me take this first. Okay, we can remove this. This, what is it called? Query string in the URL. And yeah, save. In case anyone curious, we almost hit the maximum character on YouTube description. It is 5,000 character. It is interesting. try this. Syntax error. So why is it syntax error? Is it because of the type def? No. Hold on a minute. So why is it syntax error? Interesting. What? Hello. Got new views. Okay. What's the progress? Oh, I'm currently looking at the chapter 11, which apparently trying out function pointers. So yeah, I'm still looking about the explanation of function pointers. Yeah, basically in this chapter 11 we are trying to implement variables, so we need to change something. We need to add the environment, new environment or something like that. This is the variable naming scheme, I guess. The valid character for the variable name. So by the way, which Linux do I use? Currently I'm using Arch Linux because, well, I like rolling release, I guess. And that's why in the previous session I'm trying things out because I get the newest update. That is why I use Arch Linux. So what you learn for function pointer is that we can use in pointer fun. I mean, I'm not really sure. That's what I'm trying to understand. I mean, wait, not this one, I guess. From this explanation, it's like we can assign the pointer from another function into this function pointer, I guess, and then use that as if we are using the add pointer. add function, sorry. Right, I mean in this case it might seem redundant, but yeah, from this example, so I'm not really sure yet. Okay, maybe we will wait. Hold on a minute, and not this one. See declaration. Oh right, I also found this website. It's kind of translate the C declaration to English in case anyone wants to try that. Oh, it is from the C++. Okay. That might be one of the difference, I guess, between C and C++. So that is interesting. Oh, okay. In C++, the function pointer is like that. Okay. Yeah, it's okay. I mean, at least now we know that it is kind of different, right? That's what we learn. That's why we learn together, So it's okay. Declaration. Yeah, I'm still not sure. What is this? I guess I will end the stream now. Yeah, I think I will end the live stream now because I need to grab some food. Okay, see you next time. Bye bye. Oh, which IDE do I use? Okay, let me answer this first. I use Vim. Maybe we can talk about this on the next session. Okay, see you next time.